that answer is not adequate. The sorry, um, and also say something about how mistakes about what logic is about have led to errors in the methodology that's being applied to comparing different logical systems with each other. So the usual answer to the question, what is logic about, is that it's about validity. I mean, that's something that you're likely to find on page 1 of an introduction to modern logic or anything like that. And I mean, occasionally you find books which start by saying that logic is about consistency, but since consistency and validity are interdefinable, usually that doesn't make very much difference. And so that's connected to the idea of logical consequence. I mean, so where roughly speaking, an argument is valid if and only if its conclusion is a logical consequence of its premises. So validity is just a short way of talking about logical consequence. And there's one special case of logical consequence which is of particular interest later in what I'm going to be saying, which is the case of logical truth. So normally, when we're discussing validity and logical consequence, we take the premises and conclusion of an argument to be sentences, and so it's roughly speaking the premises, we think of them as forming a set, the set of premises, but then we just have a single sentence as the conclusion. And one very special case of that is where the set of premises is empty, and in that case, we talk about the conclusion as being if it is a conclusion of, I mean, if that sentence is something that is a logical consequence of the empty set of premises, so where you don't need any premises to get it. We talk about it as being logically true or being a logical truth. So that's the sort of standard account that that is given of what logic is about. And you know, if you're a logician and you're at a party and somebody asks you what you do, and you say that you study logic, and they ask, well, what's that about? Then saying that it's about something like which arguments are valid and which are not is the kind of very quick way of saying what you do, and that gives people some idea. But when you think about logic as a discipline, you see that answer is not really very satisfactory. So, of course, one part of logic is mathematical logic, and mathematical logic has various branches. Maybe the most obvious ones are model theory, proof theory, set theory, and computability theory. And those are parts of logic in the sense that you know, if you pick up a logic journal, those are the kind of things that you'll see articles about, and if you go to a logic conference, those are the sorts of things that you'll hear talks about. But model theory is quite closely connected with the idea of validity, but proof theory much less so. I mean, it has to do with deriving conclusions from premises, but not with the usual idea of what it is for the derivation to be valid. I mean, you can get some kind of syntactic standard of validity within proof theory, so maybe you could just about say it's to do with validity. But if you look at set theory and computability theory, they don't have very close connections with validity. I mean, there are some connections, but it would be hard to say that people studying set theory or studying computability theory are really just studying validity. They're studying what those names suggest. So if you just look even simply at mathematical logic, you see that the answer that logic is about validity is not a very adequate answer to the question. And in fact, if you think about logic as a discipline which is kind of semi-institutionalized, it has its own journals and conferences, but on the whole, people who study logic are not in departments which are actually called logic. They're more likely to be in a department of mathematics or a department of philosophy or a department of computer science. So it's only semi-institutionalized. And when you look at what logic as such a discipline covers, it looks like a rather messy group of subjects, which may be lumped together more by historical accident than by the fact that they're very tightly connected with each other.
I don't know what the protocol is here, so I wrote a comment in the chat section instead of interrupting you, but I wanted to interrupt you to see if interruptions are permissible here.
I don't. I think it's probably better to leave them to the discussion.
Okay,
Rather,
no problem.
Yeah.
Okay.
Because otherwise, I think we might just get into a lot of discussion that will make it hard to
Sure. But
keep.
I just so I'll write something in the chat, maybe
Yes.
collect. Yeah.
Yeah. Thank you. So putting aside all that kind of variety, I want to focus now on the study of validity and and in particular to ask whether validity in the sense of logical consequence, whether that what we're looking at is trying to understand some pre-theoretically given standard, and that whether what we're trying to do is just to as it were formalize this notion that we already have of logical consequence. And when you articles about logical consequence, very often they're written in the spirit of, well, we've got this intuitive idea of a logical consequence, and now we want to unpack it and make it formally precise. But and it might seem that it's kind of obvious that there is going to be some pre-theoretic idea, because after all, people engaged in some kind of reasoning, and maybe even some kind of deductive reasoning long before there was a discipline of logic, and then surely they had a need to distinguish between good and bad reasoning. And so given that we need to be able to distinguish between good and bad reasoning for all sorts of reasons, that would suggest that we have some kind of pre-theoretic understanding of what this distinction is. But that's actually too quick, because the pre-theoretic conception of good reasoning is much broader than the modern conception of logical consequence, and it's broader even if we think of arguments where there's, as it were, in some sense, some kind of guarantee that if the premises are true, then the conclusion is true. Because I mean, supposing that you take the very simple argument, some coats are scarlet, therefore some coats are red, where a scarlet is just a, a specific range of shades of red. I mean, all shades of scarlet are shades of red, but some shades of red are not shades of scarlet. Um, and and by ordinary standards, the argument "some coats are scarlet, therefore some coats are red" is a it's a perfectly good piece of reasoning, and in some sense, the truth of the premise does guarantee the truth of the conclusion. But of course, it depends on the the specific relations between the color terms scarlet and red, which are generally not considered specifically logical terms, and so by contemporary standards of logical consequence, this argument is actually not a case of logical consequence, although even though it's a good piece of reasoning, so that the kind of idea that we have of good reasoning that we need in order to govern the practice of reasoning in most situations does not require anything as specific as logical consequence, the way that logical consequence is now understood. And so I think that casts into doubt that we really do have much in the way of a pre-theoretic standard of specifically logical consequence. Um, so yes, as I've said, that's a piece of good deductive reasoning, but it's not logically valid. Um, so I think it's worth looking at what Tarski says about this connection between as well the logician's idea of logical consequence and just the more general idea of good reasoning in his 1936 paper on the concept of logical consequence, which is perhaps the single most important thing written about logical consequence. And what he says there is, well, he starts off by saying the concept of logical consequence is one of those whose introduction into the field of strict formal investigation was not a matter of arbitrary decision on the part of this or that investigator. In defining this concept, efforts were made to adhere to the common usage of the language of everyday life. So there he's accepting that there is some kind of connection between logical consequence in the strict sense and pre-theoretic ideas about presumably something to do with good reasoning. But then he goes on to say, any attempt to bring into harmony all possible vague, sometimes contradictory tendencies which are connected with the use of this concept is certainly doomed to failure. We must reconcile ourselves from the start to the fact that every precise definition of this concept will show arbitrary features to a greater or less degree. And I think by arbitrary there, he means not so much unsystematic, but rather features that are not strictly justified by the ordinary use of terms like logical consequence. So that, as it were, there's an element of stipulative definition here when we're giving a precise account of logical consequence, where some of the details will be motivated not by anything like ordinary usage, but by more systematic connections, and will have to do with what is considered, a fruitful conception of logical consequence for theoretical purposes. So that, as it were, we're not simply investigating trying to find out what this concept of logical consequence that we've always had really refers to. We're trying to some extent, to engineer a good conception in roughly this area, and that's important for the methodology of the investigation because it means that we shouldn't just take all of our judgments about it, our pre-theoretic judgments about logical consequence as constraints which any account has to vindicate, because Tarski is suggesting here in that since in fact, as where this such data will be mutually inconsistent, we're not going to be able to get an account that fully does that, and we shouldn't really be trying. So it's this notion of validity that we're investigating, that logic is about, if it is about it, will be something that to some extent we have to construct, and that's not unreasonable, because we don't expect, for let's say in the case of physics, that people will be just using concepts from ordinary language. I mean every theoretical discipline is entitled to make the definitions and draw the distinctions that it finds fruitful. So the next thing I want to do is just to give a very quick explanation of Tarski's account, because it's a way of leading into an aspect of logic which I think is not really concerned with the concept of logical consequence, even though we're starting from Tarski's definition, which is of logical consequence, and so I mean, famously, the account that he gives is in some sense a model theoretic one, and so he says that a conclusion alpha is a logical consequence of a set of premises gamma, if and only if every model of gamma is a model of alpha. So of course now we have to say what it is for something to be a model of a sentence or a set of sentences. And so basically what that means is that a model is of a formula is an interpretation on which the formula is true. And correspondingly, a model of a set of formulas is an interpretation on which every formula in the set is true. And so then, of course, we also have to ask what an interpretation is, and it's in this setting, it's just an assignment of semantic values to the atomic expressions of the language that's consonant with their grammar, and it's also required to assign certain atomic expressions which are classified as logical constants, their standard semantic values. So there's a distinction being drawn amongst the atomic expressions of the language between the logical constants and the non-logical constants. I mean, there are also the variables, but what we're doing in this definition of logical consequence is varying the interpretation of the non-logical ones, but keeping the interpretation of the logical ones fixed, and then logical consequence has to do with preserving truth from the set of premises to the conclusion in all such interpretations, and that's in effect what we're talking about, where we're talking about models here. And one remark about this is that in contemporary logic and in logic since the 1950s, and partly again actually due to Tarski, we're more used to thinking of models as having one component of them is a domain for the quantifiers to range over, and a domain of objects. that is not part of the conception of a model in Tarski's 1936 account, and I think there's quite a lot of evidence that that he was quite aware of this. It's not a just some sort of uh, mischance. It's that he knows what he's doing. He know and he's not concerned with imposing a domain. And as he says things in the paper which make it pretty clear that that's how he understands it. So it's not quite the same as a modern set theoretic conception of a model, but it is a precursor of that in some way. Um, so the logical consequence on this view is to do with truth preservation as you vary the interpretations of the non-logical bits of the argument, and that is a kind of rendering of the long-standing idea that logical consequence has something to do with form rather than the content of the specific premises and conclusion of the argument. So just to take the case of logical truth, so something is logically true if and only if it's a logical consequence of the empty set of premises, and so that's equivalent to saying that it's true on every interpretation, because every interpretation makes the empty set of premises as a true. I mean, it's a model of the empty set. So in 1936, Tarski leaves it open what counts as a logical constant. He actually has a much later paper from 30 years later, in fact, that where he gives a criterion of permutation in invariance, which I'm not going to be talking about in this lecture, but anyway, the standard logical constants are words. Well, if we're taking the natural language versions of them, words like some, all, or, and, not, if, are, and is. Words which, in some sense, as it were, that feel structural. But I mean that leaves many cases unclear. And and a particular one that I think brings out the unclarity about what we might count as a logical constant is when we consider temporal operators. Of course, he was writing 20 years before the development of tense logic, and so these were not examples that were sort of in the air. But in contemporary logic, we can have operators for in the past, maybe sometime in the past, or sometime in the future, and so if we're applying the Tarskian account to those cases, we would need to make a decision about whether to count these temporal operators as logical constants, and it's not even very clear exactly how you would apply this criterion of permutation invariance that Tarski's talking about to this case. I mean, but I think on reflection, one might feel that this is really something that depends on what the purpose of our inquiry is. That I mean, suppose that we're interested in the as it were the structural properties of time and of these temporal operators, then then we might very well want to hold them fixed. I mean, hold their interpretation fixed, which is in effect to treat them as logical constants, because that's exactly what we want to study. Whereas in a different setting, we might not be interested in the specific structure of time, and we might want to abstract away from the interpretation of the temporal operators, which in effect means treating them as non-logical constants, and that might be a sensible choice for a different inquiry. So I don't myself want to be as we're prescriptive about what to count as a logical constant. I think there are different choices motivated by different theoretical inquiries. But generally, the ones that I've listed there, for most purposes, those are surely going to count as logical constants. So yes, that's what I've just said. It may depend on what questions we're trying to answer. And I mean, just to give a quick illustration of how this plays out with the example that I was giving earlier of a piece of good deductive reasoning, which is not a case of logical constants, consequences, that will come out that way on Tarski's account. Because we're presumably not going to treat the words red and scarlet as logical constants. I mean, that's where they don't seem to. There doesn't seem to be anything especially logical about them, and so if they're non-logical constants, when we're assessing the argument, we have to take into account cases where we vary, for example, the interpretation of the word red, and we could reinterpret it as for example, meaning liquid, and so then the logical consequence, sorry, the validity of the original argument would depend on whether in particular, I mean, just as one case, it would depend on the move from some coats are scarlet to some coats are liquid being truth preserving, which it obviously isn't, because it has a true premise and a false conclusion. So Tarski's 1936 account on a natural way of drawing the boundary between logical and non-logical constants is going to rule that the argument as invalid, as the conclusion is not a logical consequence of the premise, even though it's a piece of perfectly good, by pre-theoretic standards, deductive reasoning. Whereas if we were looking at the case of some coats are red, as being a conclusion drawn from the premise not all coats are not red, that would come out as valid on Tarski's criterion, because really the truth preservingness of it only depends on the interpretation of words like some, all, not, and are. It doesn't depend on the interpretation of the words coats and red, and so that's, as it were, what we might have expected. Now, the issue that I want to focus on is that the study of validity is metalinguistic. It concerns relations amongst sentences. And so if we say that logic is about validity, we're effectively, in fact, saying that logic is just metalogic, and that's what I want to question. I mean, certainly metalogic is part of logic, but the question is whether it's all of logic. And this is, in addition, forgetting about things like set theory and computability theory, which, although they have some connection with validity, it's a fairly distant uh, one. And so, are also problems for the idea that logic is about validity. But just concentrating on this kind of stricter understanding of what to count as logic. Um, so what I'm going to do is to focus on one of the roles of logic, and then later a second one as well, where it seems the focus is not so much on the on these metalogical issues. Even though the logical and the metalogical are quite hard to separate. So, um, so just as a definition, so supposing we have a set of hypotheses gamma and some consequence relation lambda, then this thing, the theorems of gamma under lambda that's how I read it. It's a set of consequences of gamma under lambda. So it's just all the things. So we've just got a set of sentences gamma, which we're treating as hypotheses, and then this is just how we talk about all their consequences. So I mean that's just the definition. Doesn't really advance things yet, but so this set of theorems, which can also be called the closure of gamma under lambda. It's really going to be about whatever aspects of the world gamma is about. So, for example, if gamma comprises some principles of physics, then we can regard the closure of gamma under lambda as a theory of physics. And the sentences in this theory these are the sentences in the object language. They're not sentences of the meta language, and so this is the role of logic as drawing out consequences from a given proto theory. I mean, just a set of principles or hypotheses or whatever they are. And when we're testing the theory of physics, we're also testing the logic that is being used, as it were, to articulate the consequences of these original hypotheses. And if things go wrong, it may be that the logic is to blame. So, for example, if we had a logic which had the monistic theorem that which really says that there's at most one thing, that for all y x equals y, then obviously, I mean, this is a very extreme case, but obviously if we combine that with principles of physics, we would get some kind of complete collapse, and what we got would certainly be a bad physical theory. It was certainly inconsistent. So um, so that in effect, when we're using logic to articulate the consequences of theories, when we come to test those theories, we're also testing the logic as well as the initial hypotheses. And of course, I think the most severe test of consequence relations is their closure role in mathematics, where we're seeing what we can get from the mathematical axioms by applying logical consequence, by closing the axioms under the given consequence relation. Now, I mean, so far you might think, well, aren't we really just still talking about validity? Although I think actually what's going on is that we're treating the um, the logic as a kind of theory in the object language, um, and just I mean, we should beware of um, kind of in a sort of cheap way um, making everything metalinguistic. So, I mean, which because that's something that you can do with pretty much um, any discipline. So you could say, well, if you look at physics and you took the language of physics, and then you could say, so what physicists are interested in is which sentences in the language of physics are true. And then you could conclude from that this is some kind of metalinguistic inquiry that physicists are carrying out. But I mean, obviously, that would be an absurd way of thinking about the object of inquiry in physics. It's an inquiry into the physical world, and we're just using language to talk about it. And I think some to an extent that isn't always appreciated, something like that goes on in logic as well. And so I think maybe we can see that best by taking the special case where the this set of hypotheses is just the empty set. And that really takes us back to the case of logical truth. Um, and there, what we're going to be considering is a result of universally quantifying each constituent of a given formula, except for the logical constants. And I mean, I'll call that um, the universal generalization of alpha. But remember that it's a generalization that generalizes on all the non-logical constituents as well as the variables in alpha, if any. And so what we get from Tarski's account is that the logical truth of alpha just corresponds to the plain ordinary truth of the universal generalization of alpha. I mean, when you look at the way his account of logical consequence goes in the special case of just logical truth, that's really the effect that you're because you're just generalizing on all these bits, on all the non-logical bits of alpha. And so when we're considering the logical truth of a formula, we're in effect considering the ordinary truth a of its universal generalization in the sense that I explained. And these universal generalizations of logical truths, they're non-metalinguistic structural laws of, well, you can say logic, but you can also say metaphysics, because they're laws in the object language, which is not a metalinguistic um, in the cases that they're interested in. And so they're just, as it were, in effect, laws of about reality. And so just to take a couple of examples. So suppose that um, we just take the case of self-identity, A equals A. And so presumably that's going to be logically true, because it's true on every interpretation of the name A, because an interpretation is just going to assign it some particular object or other. It's got to assign it some object, and so A equals A will be true under all the relevant interpretations, because the identity sign is a logical constant, and so that bit is not being varied. And so the logical truth of A equals A is equivalent to just the ordinary truth of for all x equals x. In other words, everything is self-identical, and that itself is I think qualifies as a law of metaphysics. Um, and if you think, but isn't that terribly trivial? I would just say two things. One is for simplicity, I've chosen a very, very simple logical truth, but also it's not even um, completely uncontroversial. There are metaphysicians who hold the view that nothing is self-identical. And I mean, of course, they're wrong, but it's not as though this is something that no sane person would deny. Now, the thing is, it's going to, if you look at for all x equals x, for a formula of that kind, which doesn't contain any non-logical constants, there's nothing to vary on, in Tarski's way, and so truth and logical truth will coincide for such a formula, and so as it were, the plain formula in effect is equivalent to the metalinguistic claim that for all x equals x is logically true or valid, which I'm using the turnstile there to symbolize. But we don't have to be just interested in the metalinguistic fact. We're interested in this just as a generalization about identity. There's nothing metalinguistic at all in the statement that for all x equals x, and so as well, this is a truth about reality, and it's a kind of truth that we're actually interested in metaphysics, and so something that logic is supplying us with in this kind of way is just truths of metaphysics, metaphysical laws, if you like, and there's no reason for thinking that the metalinguistic claim has any kind of explanatory priority to the pure object language claim that everything is self-identical. And so that's a piece of that's something that we've, as it were, through logical reflection, a conclusion that we reach, which is not itself in any interesting sense about validity. It's not a metalinguistic truth at all. And just to change the example, to go to the law of excluded middle, you could say if A or not A is logically true, I mean, I think it is, then the universal generalization for all P or not P is going to be a law of metaphysics. And for all P or not P is a natural way to articulate the law of excluded middle. It's the variable there is taking, as you can see, is taking sentence position rather than name position, because it's being negated and joined by disjunction, and so we're doing a bit of higher order logic here, and in general, to get these universal generalizations, we'll often have to go to a higher order language, but I don't think that's a bad thing. And again, once we're dealing with this universal generalization, we're dealing with something which will be true if and only if it's logically true. But again, that doesn't mean that we have to take the metalinguistic claim as having explanatory priority. I think we might well take the priority being the other way round. So those are just a couple of examples of the kind of thing by saying that logic is giving us these laws of metaphysics. And the thing is, these truths, these laws, are of interest to us because they're so general and structural, and it's clear that if any discipline is going to tell us about them in a rigorous way, that discipline is going to be logic itself. So that there's a a task for logic of giving us information, as it were, about the world, giving us metaphysical laws, which does not fit the idea that logic is all about validity. I'm not saying that none of logic is about validity. I mean, because as I said before, metalogic is a valid, legitimate branch of logic, but we shouldn't allow the salience of metalogic to hide from us the fact that there's also this, in a way, more basic task for logic of just getting these worldly facts right. I mean, they may be necessary, but they're still just about reality. They're not about language in any sense. So in the final part of the talk, I want to go on and talk a bit about the natural methodology to apply when we're thinking of logic in this way. So for deciding between rival logical theories, for these kind of object language roles for logic, the closure and metaphysical roles. And I'm not going to give an extended defense of this, but I think the natural methodology is an abductive one that would people sometimes talk about inference to the best explanation, as abduction, and you could understand it this way as long as you understood that the kind of explanation that we're getting is just bringing things under illuminating generalizations. It's nothing to do with causal explanation. So I think there's actually quite a lot of interest in the idea of an abductive methodology for choosing between rival logical theories or rival consequence relations for the as candidates to play this kind of closure and metaphysical role of logic, and so that's a methodology which is widely used in theory comparison in the natural sciences, and very crudely put, what we're doing is we're deciding between these logical systems on grounds of simplicity, strength, and fit with evidence. And the evidence here is just whatever it is that we already know. It doesn't have to be particularly observational evidence, but in logic, there's evidence because we already know lots of things that we state using negation, quantifiers, conjunction, disjunction, conditionals, and so on, so that we've actually got already quite a lot of specific knowledge of a kind that is relevant to logic. And once one's dealing with competition between, let's say, between classical and various non-classical logics for this role, there isn't really any very obvious alternative for the methodology for deciding between logics. Now, I want to consider an objection which has been made to the use of the abductive methodology and respond to it. And it turns out that the kind of more specific response to it will actually connect with a lot of what I've been saying before. So so the objection is that both classical logic and dialetheist logic have been defended on abductive grounds. So I've defended classical logic on those grounds, and Graham Priest has defended dialetheist logic. I mean, that's a kind of non-standard sort of logic where you can assert contradictions and you won't get just a complete collapse because not everything follows from a contradiction. And so the objection is, well, doesn't this show that abductive methodology is kind of impotent, because it can't actually decide between two radically opposed views? So I think there's a generic reply to that, which is that, of course, you get lots and lots of disagreements in natural science where all sides are accepting the abductive methodology. And this doesn't show that the abductive methodology is impotent in natural science. Um, it just shows that there can be disagreements about how to apply it. And so I don't think that it's a kind of devastating objection. It just, as it stands, even if you um, you really have got nothing more specific to say. I think if logic is being in some ways compared to the natural sciences, we might expect such disagreements. But I think there's also a more interesting and specific reply, which I want to go into in a bit more detail, and that is that many proponents of the abductive methodology, and so I'm thinking of Graham Priest, but Gillian Russell is another, and then there are various others. I think they've misapplied this methodology for a very specific reason. It's because they have treated logics as theories of validity. And in particular, when they've done that, it's resulted in a misapplication of the criterion of strength. And so, one of the most obvious advantages from an abductive perspective of classical logic over non-classical alternatives is that it's stronger. And I think by obscuring what is meant by this criterion of strength, the effect of that has been to obscure what one of the most important advantages of classical logic is over most non-classical logics. So just to state very quickly what strength is a matter of, roughly speaking, of informativeness. And so if we're talking about the strength of logics, and here I'll be assuming that the logics are all in the same language, because things get much more less clear once you have logics and comparing a logic in one language with a logic in another language. But if we're talking about theories T and T star in the same language, then the standard understanding of logical strength is that T is logically as strong as T star, if and only if the theorems of T star form a subset of the theorems of T. And then T is stronger than T star, if and only if T is as strong as T star, but T star is not as strong as T. So that's how logicians usually talk about the strength of logic. I mean, there are some other ways of talking about, but this is a very fundamental. I mean, so for example, when people are talking about which modal logics are stronger than which other ones, which is a kind of comparison that they're usually making in the setting of background classical non-modal logic. That this is the kind of criterion that they will be using. And if we want to generalize it to logical consequence relations, we just have to take I mean, basically, rather than talking about the strength, or just in terms of sets of sentences, where we have just look at sets of pairs of sentences and sets of sentences understood as the premises, which are cases logical consequence according to the given consequence relation. But as we'll see, if you judge strength in terms of theories about logical consequence, this kind of very standard approach to the criterion of strength in logic gets disrupted. And you can see this by considering a very extreme case, which is the theory that the only logical consequences of a set of premises are those premises themselves. So this is the extreme view that logic never gives anything new at all, in its most extreme form. And so that means that when you take the closure of a set of hypotheses under this minimal consequence relation, all you get are the original hypotheses. Nothing at all is added to them. And so that consequence relation, if we, it's pathetically weak in the closure role of logic. It's far too weak for purposes of natural science and mathematics, because obviously in both of those, it's absolutely crucial that you can derive rich consequences from initial hypotheses. So it seems that, this consequence relation is really a non-starter for the closure role of logic in natural science and mathematics. But if you instead think of it as a theory about validity, it's extremely strong. It tells us all sorts of surprising and indeed, in fact, obviously false things about validity. I mean, it tells you that most of the, that, for example, modus ponens is not a valid form of argument, and conjunction elimination is not valid according to this criterion. And so it's very, very important that you separate the consequence relation itself from the claim that that correspondence relation corresponds to validity in some other sense. And I think what's been going on in a lot of the of this work, particularly by people who are sympathetic to non-classical logics, is that when they come to making comparisons of strength, they look at theories about validity and compare their strength rather than comparing the strength of the object language logics. And, as this example brings out, I mean, you get radically different results if you do that. And so, as it were, in order to apply the abductive methodology correctly, we have to understand the consequent relation at the level of the object language, not the meta language. So that's a way in which, by thinking of logic as being about validity and taking that to an extreme, that you can get very, very unfortunate results in something which matters quite a lot, which is the comparison of different consequence relations as candidates for being the intended one. And intended one that, as the one that would be appropriate for the closure role of logic in natural science and for the metaphysical role of logic that I was talking about. There's one little wrinkle which I'll quickly go through, which is that for abductive purposes, we actually need something more general than just the strict logical relation of consequence. So one theory may be, and as I call it, scientific strength. One theory may be scientifically stronger than another, even if neither is included in the other. So there's, just as an example, I'm going to take GR to be the conjunction of the equations of general relativity as universal generalizations. Okay, so this example doesn't really depend on anything specific at all about general relativity. It's just it was just to give a particular case, and then we've got the two theories. One of them is the theory of general relativity. So as it were, the closure of GR under logical consequence, and the other is the closure of not GR under logical consequence. And remember that not GR is it's a particular sentence. It's because we GR was it's a conjunction of universally generalized equations. So it's something that you can negate in a straightforward sense. Now, both GR and not GR, they're both consistent. I mean, they're because I mean, obviously, GR is consistent and not GR is consistent because if it weren't consistent, GR would just be a logical truth, which it isn't. And so that means that neither of the theories that they generate is going to be a subset of the other, because if it were, then we would get an inconsistency. But in an informal sense, we can still say that the theory of GR is far more informative than the theory generated by not GR, because not GR it just says, look, there's something wrong, something is wrong with GR somewhere, and doesn't specify anything about what specifically is wrong with GR. And so that's a very uninformative theory. So uninformative, in fact, that I think physicists would not really consider it as, an alternative theory of physics at all. But but still, we can think of it in principle, and so we've got that one of these theories, as well, is far more informative than the other, even though neither entails the other. And there will be similar cases in logic. So, for example, supposing we have some version of intuitionistic logic with higher order quantification, so we can quantify into sentence position, and then we could add to intuitionistic logic the negation of the universally generalized law of excluded middle, because intuitionists do think that that universally generalized claim is not the case, that it would be absurd to have a proof of it, even though within intuitionistic logic you can't consistently negate individual instances of excluded middle, but you can consistently negate the universal generalization. And so there, if we compare intuitionistic logic with that theorem, with classical logic, neither of them is as it were, entails the other. Neither of them is strictly included in the other. But still, intuitionistic logic is, in this informal sense, is scientifically much weaker than classical logic for most purposes. It's just it will get you far less in the way of consequences from a set of assumptions, and it will give you a far less informative set of theorems at the level of metaphysical consequence. So what this shows is that the case of even if we just to complete that, so when we're making abductive comparisons, we're talking about comparisons in respect of strength specifically, then the notion of strength that we need is scientific strength rather than purely logical strength. But even when you make that qualification, the example of the weak logic lambda that I gave, which can't generate anything new from the premises, that still shows. It's still a case of extreme abductive weakness. So it doesn't alter the point that for abductive comparisons, we need to be thinking about logics in the object language rather than metalinguistic theories about validity, about what's a logical consequence of what. So that's really the end of the talk. So what I've argued is that not all of logic is about validity. So some of it is about it, but there's a more basic task for logic, which is just, as we're telling us, roughly speaking, very, very general structural facts about our reality, and that we shouldn't neglect that role of logic, both because it's important in itself and also because in the way that I've just illustrated, when you get sort of confused about the relations between logics and metalogics, this is actually going to lead to mistakes in ranking logical systems because you're not applying the criterion of strength in the correct way. And thank you very much. I will stop sharing now.